Recording started.
Hi Science 24 students. In this session, we're going to go over a number of important concepts and questions that will help you to do well on Tuesday's test. So what I would recommend doing is, first of all, watching this recording, and then after you've watched it, then complete all the questions here. So after all the information is presented, then there's questions that you can complete. And I'm going to be sending you guys out a file, and so you'll be able to use that file. So don't worry if you can't complete all these questions as we're going through the material, because after you watch the recording, then you can do it afterwards. Okay, so first of all, we can see there's some sort of a chemical here. We don't really know what kind of chemical this is, but it turns out that it's a herbicide, and we're going to talk right here at this point about the difference between herbicides and pesticides. Okay, so herbicides, as the name suggests, kill plants, or herbs, right? And they kill, specifically we want them to kill weeds. So these would either be weeds that are growing in our garden or possibly on a farmer's field. Whereas pesticides, on the other hand, would kill pests. And a lot of times we're talking about insect sort of pests. So the question here that we would have at this point would be blank kills insects while blank kills weeds. So think about which kind of chemical would go in each of those blanks. Alright, so now on to the next one. At this point we're going to talk about the differences between natural chemicals and man-made chemicals. And we looked before about the differences between natural and man-made fibers. So for instance, something like cotton was a natural fiber, whereas something like polyester was a man-made fiber. And so when we're talking about man-made chemicals, another name for these is synthetic chemicals. Alright, so think about what's going to go in each one of these blanks. Blank chemicals occur naturally, while blank chemicals are man-made. So what's another name for man-made? On to the next page. I don't know if you guys have ever made soap before, maybe at home or maybe at school before, but what happens when we make soap is we use something called lye, and we react it together with a fatty acid. And lye is a type of base, and later on we're going to look at the fact that whenever you mix an acid and a base together, that's called a neutralization reaction. But the question here we want to focus on at this point is to name the two types of chemicals that react together to produce soap. So what do you think those would be? Alright, so moving along, we see we have a nice shiny rim here, and that's made out of what's called an alloy. And an alloy is two different kinds of metals. So why do you think we might want to mix chemicals together, or rather mix alloys, mix metals together to produce an alloy? Well, the benefit of an alloy metal over a regular type of metal is that they're usually stronger, and they're also often more rust resistant than other types of metals. So for instance, you might have some stainless steel kicking around your house, you know, in your utensil drawer. You've got a lot of stainless steel knives and forks, and so that would be an example of an alloy. So thinking about the blank here, then we have to fill in. Stainless steel is an example of a what? What do you think would go in that blank? Alright, on to the next page. We see we've got the picture of Coke here. I don't know if you guys prefer Coke or Pepsi. I probably prefer Pepsi a little bit, but pretty much the same. And what's the main ingredient that produces the fizz in Coke or Pepsi? Well, that's carbon dioxide. So carbon dioxide is a really important gas. It produces the fizz and pop. It also produces, it also causes breads to rise. Okay, so what's actually going on is you've got the yeast organisms that's growing in the bread, and it produces carbon dioxide gas, and then it causes the bread to rise. Now you guys have probably heard a little bit about global warming or the greenhouse effect. Well, those things are a result of too much carbon dioxide gas in our atmosphere. So maybe you've seen one of these movies about, you know, like the polar ice caps melting and that sort of thing. And again, it's a result of too much carbon dioxide. So think about what you would put in here. Blank is the gas involved in pop and also when bread rises. And the next question here says, too much carbon dioxide in our atmosphere can lead to global warming and the blank effect. What's another name that often goes along hand in hand with global warming? Okay, so on to the next section here. It just talks about the fact that chemical reactions are going on all around you, and many of them you can't even see. They're going on inside your body. But a lot of times chemical reactions in your body are to give you energy. And so a lot of times we're breaking down things like carbohydrates and fats, and cellular respiration is a process that breaks down carbohydrates such as glucose, and so this gives you immediate energy. So when you break down glucose, which is a type of sugar, that's going to give you an immediate source of energy. And that's what we want if we want to do basketball, if we want to do some sort of sport. All right, now on to the next section here. We're going to talk a little bit about cellular respiration, a bit more about that. Cellular respiration, again, is when you're burning some sort of sugar in your body, such as glucose, and you're using that to produce energy. And so that is an example of a combustion reaction, and what takes place as well is burning is always taking place in any sort of combustion reaction. So the chemical reaction for cellular respiration is glucose and oxygen.
Recording started.
So here we look at the formula for cellular respiration, and we can see that what happens is glucose is burned in the presence of oxygen, and we can see that there are three different things that are produced when we're talking about cellular respiration. So there are carbon dioxide, water, and energy. Okay, and now at this point we're going to look at the difference between exothermic reactions and endothermic reactions. The way I like to remember the difference between exothermic reactions and endothermic, I think about the word exo, and it sounds like exit, and so heat exits or heat leaves during an exothermic reaction. And so if you've got something like an explosion, which is an exothermic reaction, it makes sense that heat would leave or heat would be produced. An endothermic reaction is the opposite. Heat is used up. And so because heat is used up from the environment becomes colder. And if you take some vinegar and baking soda and mix it together, that's an example of an endothermic reaction. So that's just telling the difference between the two. So at this point, we need to fill in this blank. Cellular respiration is a type of what reaction? And we're not talking here about exothermic or endothermic. If you read this section here, we'll be able to figure out what type of reaction we're talking about at this point. Okay, so the next question we look at here says, name all of the substances produced in the process of cellular respiration. And remember that the products are the substances that are produced in a reaction. And it kind of makes sense, right? The two words go together, products and substances produced. So if you look back at the process of cellular respiration, think about which products are produced.
You have new mail.
Okay, now the question we're going to try to answer at this point, cellular respiration produces what kind of reaction, and is therefore, produces what sort of a substance or what sort of a thing, and is therefore what kind of a reaction. Now, what we're looking at here, this blank is trying to tell the difference between an exothermic and an endothermic reaction. So keeping that in mind, what do you think it produces, and which of these two do you think it would be? Would cellular respiration be an exothermic reaction or an endothermic reaction? Okay, good stuff. So, on to the next page. You can see here we have a picture of an antacid, and maybe at some point you guys have had like a sore stomach and maybe your mom told you to try an antacid. Well, what is an antacid again? Well, like the name sort of suggests, it kind of does the opposite to what an acid does. And we know that a base and an acid always do the opposite to one another. So the antacid contains a base called magnesium hydroxide. The magnesium hydroxide reacts with hydrochloric acid, which is in your stomach. That's what's making you feel sore. And that is going to produce magnesium chloride and water. So whenever an acid and a base react together, this is a neutralization reaction. So an acid neutralizes a base and it becomes less basic, and a base neutralizes an acid and it becomes less acidic. So both salt and water are produced whenever you have a neutralization reaction. So it's important to memorize this reaction here. An acid and a base produce salt and water. And so that's an example of a neutralization reaction. And it kind of makes sense because when you think about the fact that the acid and base are neutralizing one another, we know that a neutral pH is 7. And we know that water has a neutral pH, and also salt does. So that kind of shows that an acid and base are canceling out. So the question here is, when you have an acid and a base reacting together, what type of reaction is that? And that's what we're going to put in this blank here. And so at this point we'll just talk about some of the differences between acids and bases. Now, acids are sour, they have a pH less than 7, and they're neutralized by bases. And a lot of times the bases that are used to neutralize an acid are oxides. Bases, on the other hand, they're very slippery. So if you've got a soap, that would be a base, right? And bases have a pH greater than 7. Okay, so those are some important ways to differentiate between acids and bases. So now what we want to do is, this question says, in the paragraph above, the chemical mentioned that must be a salt is, okay, so what chemical would that be? So what you need to do is look at what the acid-base reaction was and what would the salt be that was being produced. So remember, the magnesium hydroxide, that was the base. It was canceling out the acid. And so just read on and see what you think the salt would be, and that's where you would write in this part here. Okay, on to the next page. And so the next question we're going to have, tell 2 different things about acids and 2 different things about bases. So for instance, we talked about, some of them were slippery, some were sour, and
You have new mail.
also we talked about what their different pHs would be. Okay, so that's some of the things you're going to write for this question here. Well, we see here a picture of some sort of a chemical reaction going on, right? So, whenever a chemical reaction takes place, there's always some sort of an evidence that the chemical reaction is taking place. So, for instance, if there's a carbon dioxide gas being produced, well, you're going to see some bubbles, right? And those bubbles are evidence that the chemical reaction is taking place. Another thing that can happen is when you mix 2 chemicals together, you can actually mix 2 liquids together, and you might have a solid being produced, even though you mix 2 liquids. Well, when that happens, that new solid that's being produced is called a precipitate. Okay? So again, those are 2 examples of things that you can see that are evidence of a chemical reaction taking place. Bubbles being produced or a precipitate happening. And those are evidence of a chemical reaction. Now at this point we're going to look at some different types of chemical reactions. We've already looked at combustion reaction, whenever something explodes or burns. But we're going to look at something called a decomposition reaction. Well, what does that word decompose mean again? Well, to decompose means to break down, right? So a decomposition reaction is when some sort of a substance breaks down into the chemicals, for instance, often the elements that make it up. So here you can see that you have H2O, and it's breaking down into both H2 and O2. So that's why it's called a decomposition reaction. Okay, let's have a look now at a reaction that's the opposite of a decomposition reaction. Well, that's a composition reaction. When we talk about composing something, that's putting it together, right? If you compose a piece of music, you're putting it together. So here, you're putting together the elements into one substance, right? We're putting together Na and Cl into NaCl. So that's why this is an example of a composition reaction. Again, the opposite of a decomposition reaction. So, just to remind you, sodium chloride is another name for table salt. So if you're putting some table salt on your food tonight, you can say, hey, I'm putting on some sodium chloride, right? All right, so one thing that's important to remember is both of those reactions that start with C, a combustion reaction, and a composition reaction, both of them produce energy. We already knew that with a combustion reaction. We knew that it was burning something. We knew that it were exploding something. But a composition reaction as well produces energy. Now, another important thing to remember about combustion reactions, they always require oxygen to work. You can't burn something without oxygen, right? Now, there's always three things that are produced in a combustion reaction, and that's water, energy, and carbon dioxide. So if you look at this example of a combustion reaction, you can see again that oxygen is needed, and you can see again that carbon dioxide, water, and energy are the three things that are being produced. So looking at our next question, okay, sorry, we don't have it quite yet. One more thing just to mention. Sometimes when you're burning something, it goes all the way to completion. But sometimes your combustion reaction doesn't go all the way to completion, and it's called an incomplete combustion. Okay, so the question you would have at this point is to define each one of those types of reaction. Okay, so define a decomposition reaction. What happens in this kind of reaction? Define a composition reaction, and define a combustion reaction. Okay, so think for a moment. A combustion reaction requires something. What always needs to be there for a combustion reaction to occur? And what were those three things that were produced? So look back at the equation we looked at on the last page for a combustion reaction. And what are those three things that are going to be produced? Now, for this blank here, what I was looking at is what some of those evidences were of a chemical reaction taking place. So for instance, when a gas was produced, what do we see happening when a gas is produced? That's where you're going to put in this blank. And when we have some sort of a new solid being produced, for instance, if you take two liquids, mix them together, and get some sort of new solid, what do you call that new solid? All right. What we're talking about at this point now is a lot of times when you look at some sort of a chemical reaction taking place or being written out, so for instance you might see H2O is going to produce H2 plus O2, a lot of times you'll see a letter beside like the H2O. And this here should not say S stands for liquid, it should say S stands for solid. It should be L stands for liquid, right? So after water you might have an L there. After say iron metal you might have an S there for solid. And G stands for gas. And here's a really important one. AQ stands for aqueous. And what that means is that you have one substance dissolved in another substance. So for instance, if you had salt or NaCl dissolved in water, after the NaCl, if you were writing out that equation, you would write a little AQ for aqueous. All right. So the next question you'd be answering here says, what do the letters S, L, and AQ stand for in reactions? So think about that, what each one of those would stand for. Okay, so now we're going to have a little bit of a practice at looking at an equation and telling how much we have of each type of atom. So for instance, here we have 3 hydrogens and we have another hydrogen. So how many do we have in all? We have 3 in one, and that's going to make 4 in all. So you would write 4 in this blank, and then look above and figure out how many C's or carbons you would write, and how many oxygens you would write. How many oxygens are in this? Okay. Now, whenever you have a chemical reaction, you have something new being produced, right? It could be energy, but it could be something else new that's produced. So for example, you could have some new color produced, and that's an evidence of the chemical reaction. Or you could have some more heat energy, that's something new. Or light being produced, that's something new. But not all times when you have a reaction take place is it a chemical reaction. So for instance, if you take a solid and you melt it so it goes to a liquid, that's not a chemical reaction, that's just called a physical change, because nothing new is being produced. It's just what you call a change of state. Remember, when we talk about solid, that's one state of matter, and liquid is another state of matter. So whenever you have just a state of matter happening, that's not a chemical change, it's just a physical change. And I put this little snowman here just to remind you that, we're talking about melting here. Okay, good stuff. So at this point, we're just going to talk about some different numbers that are involved in chemical equations. So sometimes we have these big numbers that are in front of these chemicals. Well, what are those? And also we have these little numbers. What are they? Well, the numbers in front of chemicals, like this 2 in front, so we have 2HGO, those are called coefficients. And the small numbers that come after an element and are down below, like this little 2 with oxygen, those are called subscripts. So the question you have here is, what is the difference between coefficients and subscripts? All right, we're going to talk a little bit more here about different chemical reactions that take place in our environment. Some of them are not so good. Now in Alberta, we have a lot of coal being burnt, and it produces sulfur. Specifically, the sulfur is in the form of something called sulfur dioxide. So to get rid of that sulfur dioxide, or to prevent it from going into the environment, a lot of times you might see something called a scrubber that's put on one of those long tubes that puts the chemicals up in the environment. And so again, scrubbers are used to stop sulfur dioxide from going into the environment. But we don't want sulfur dioxide going in the environment because that produces something called acid rain, which is not good. All right, so here we're just talking about the fact that another name for rusting is corrosion. And the substance that normally is corroding the most in the environment is iron. So for instance, you might have seen on a fence post an old iron nail, and you see it looks something like this, right? Okay, so corrosion is iron. And now it's important to remember that the rusting of iron is a single decomposition reaction. Now there are ways to reduce the corrosion of iron, or rusting. There's 3 different ways. One thing we can do is we can put a metal on top of another metal. And the metal that's put on top of the other metal that prevents rusting, the metal that's on top is called a sacrificial metal. And often we use magnesium as a sacrificial metal. That's one way of preventing rusting. There's 2 other ways. One is to put paint. You put paint on something and you're keeping the oxygen and water from being able to get to the metal. So you're preventing the rusting that way. And galvanizing is another way of protecting the metal. Okay, so a few questions to think about. What's another name for rusting? And what's a metal that rusts a lot? And the last, or second last question is, which metal is often used as a sacrificial metal? So again, just read up above. And now, what are the 3 different methods we talked about for protecting metals? All right, so now we're on our last page, and at this point what we're going to talk about is some different chemical formulas and what the common names are for each one of these chemical formulas. And the first thing I want you to know is that the CO3 stands for carbonate, okay? And it kind of makes sense that this one would be calcium carbonate because Ca is the first two letters of the word calcium. So this one's probably fairly easy to recognize that this is calcium carbonate. Now this one is baking soda. I'm going to go to the fourth one now. This is actually what's called sodium bicarbonate. And if you can remember that sodium bicarbonate is another name for baking soda, that will help you to remember this one because it's got this carbonate in it, and we also recognize that as sodium. Okay, so sodium bicarbonate, again, it's got carbonate in it, and that's baking soda. Now, to remember the formulas for the last ones, if you just think about the fact that ethanol ends in an OH, anytime you've got an all sort of a chemical, like ethanol or methanol, it always ends in OH. All right? And now for glucose, if you just remember the fact that glucose is C6H12O6, just remember that glucose has either a 6 or something, you multiply by 6, which is going to be 12. Well, 2 times 6 is 12. Maybe that will help you to remember what glucose is. So again, glucose is C6H12O6. So guys, I really want to emphasize how important it is to watch this whiteboard recording and to, after you've watched the recording, to practice the questions that are going to be on the sheet. So all those questions we've been working through as we've been working through this recording, they're all going to be on another sheet that I'm going to send out. And so what I would do is watch the recording, and after you've watched it, then practice all those questions. Make sure you're able to get all of them, and if you can get all those questions, that should help you to prepare fairly well for the test on Tuesday. So again, watch this recording really carefully, practice all those questions, and you should be pretty set for your test on Tuesday. So thanks for watching this recording, guys. I want to wish you an awesome weekend. Take care and have a great day.